Bismillahirrahmanirrahim. Today we will start the chapter bone, joints and soft tissue. First we will discuss the diseases of the bones, then later on joints and soft tissues. So what are the different types of proteins which form the bones? Type 1 collagen is most abundant, 90%. Then cell adhesion proteins, calcium binding proteins, proteins involved in mineralization, enzymes. Then there are growth factors like growth factor 1, EGF, beta, PDF, GF, cytokines, prostaglandins, interleukin 1, interleukin 6, rank L. Then there are proteins which are concentrated from serum, beta-2 microglobulin, albumin, insulin like growth factor, transforming growth factor, platelet-derived growth factor. So all these proteins, they affect the bone metabolism. Then minerals of the bones, hydroxyapatite, calcium, phosphate, hydrox. So composition of the bones. So there are calcium, 39%, potassium, sodium, magnesium. These are the minerals. So total inorganic components, 67%. And then organic compounds, mostly collagen type 1, which forms the extracellular matrix, 33%. So what are the cells of the bones? So osteoprogenitor cells, which are stem cells, and they give rise to other types of cells. Then osteoblasts, they are present under the surface of the spicule and they are under the control of calcitonin to take blood calcium and put into bone. So they are bone forming cells, osteoblasts. Then osteocytes, they are osteoblasts which are now completely surrounded by bone. And then osteoclasts, they are derived from circulating monocytes and they are under the control of parathyroid hormone. And they chew up the calcium of bone and put it into the blood. So there are 4 types of cells of bone: stem cells, osteoprogenitor cell, osteoblasts, osteocytes, and osteoclasts. So osteoblasts, they are bone generating cells. B means building. Osteocytes, they are mature bone cells, spider shaped and maintain the bone tissue. And osteoclasts, they destroy the bones, bone destroying cells. C mean here chewing of the bone. Osteoblasts, osteocytes, and osteoclasts. So normal bone metabolism is influenced by various factors and hormones, growth factors, transforming growth factor beta, EGF, fibroblast growth factor, then various types of cells, monocytes, macrophages, osteoclasts. So what is woven and lamellar bone? So in the woven bone, the collagen is raised haphazard And in lamellar bone, it is lamellar bone, there is longitudinal arrangement of the collagen, and woven bone is easily fractured due to haphazard arrangement of the type 1 collagen. So that was about the various types of cells and composition of bones. So what are the systemic factors which affect the bone metabolism? Cortisol, estrogen, progesterone, testosterone, vitamin D, prostaglandins, interleukins 4, 18, interferon gamma. So then there are local factors, bone morphogenetic proteins, are basic morphogenetic proteins, fibroblast growth factor, insulin-like growth factors, TGF-beta. So bone diseases. Bone diseases may be congenital, they may be metabolic, they may be inflammatory, they may be neoplastic. So congenital malformations, diseases associated with defects in extracellular structural proteins like type 1 collagen disease, that is osteogenesis imperfecta, and other collagen diseases. Then diseases associated with defects in folding and degradation of macromolecules, mucopolysaccharidosis, diseases associated with defects in metabolic pathways. So there are various types of congenital diseases. So malformations and diseases caused by defects in nuclear proteins and transcription factors, congenital absence of a single bone, phalanx, rib, or clavicle, supernumerary digit. Then diseases caused by defects in hormones and signal transduction mechanisms. Achondroplasia. So achondroplasia is a point mutation disease that is usually arginine for lysine 375 in the gene that codes for FGF receptor 3 on chromosome 4p. So this is achondroplasia, dwarfism, short arms, extra folds of skin. So then congenital diseases which result from defects in extracellular structural proteins, that is collagen type 1, that is the osteogenesis imperfecta. Brittle disease or brittle bone disease or too little bone disease. Biliosclera, it affects joints, eyes, ears, skin, and teeth. So mutations in genes which code for the alpha 1 and alpha 2 genes of the collagen type 1. And then mutations of collagen 2, 10, and 11. They manifest as cartilage diseases. Osteogenesis imperfecta. Biliosclera due to defect in the collagen in the sclera, the posterior choroid is seen as blue colored. So that is about the congenital diseases. So osteoporosis, They are the disease associated with defects in metabolic pathways, that is enzymes, ion channels, and transporters. Osteopetrosis, marble bone disease. We also call it as marble bone disease. Bone is brittle and easily fractured. There is decreased osteoclast resorption due to there is carbonic anhydrase deficiency. So you must remember the names and some pathogenic defect. So then is the osteoporosis. So this is very common disease. Peak bone mass is achieved in early adulthood, and a normal decline of bone mass is very slow. But osteoporosis is seen when there is accelerated bone loss. And there are various factors which are associated with osteoporosis: age, physical activity, then hormones, that is estrogen withdrawal in females, nutrition, and genetics. So various categories of generalized osteoporosis. So one is primary, that is postmenopausal, senile, and idiopathic. And then is secondary due to other disorders, for example, endocrine disorders, hyperparathyroidism, hyperthyroidism, hypogonadism, pituitary tumors, diabetes type 1, Addison's disease, then neoplasia, for example, multiple myeloma, carcinomatosis, then gastrointestinal, malnutrition, malabsorption, hepatic insufficiency, vitamin C and D deficiency. Then there are drugs, anticoagulants, chemotherapy, corticosteroids, anticonvulsants, alcohol. Then osteogenesis imperfecta, immobilization, homocystinuria, anemia. So all of these secondary diseases, they can lead to osteoporosis. So osteoporosis, decreased bone mass. Senile osteoporosis is called low turnover variant. So age-related changes in the bone cells and matrix, osteoblast cell, reduced proliferative and biosynthetic activity in the older patients. The bone cells, that is bone forming cells, osteoblasts, they are deficient in proliferation and biosynthetic activity in the older age group. And proteins bound to the extracellular matrix, they lose their biologic punch over time. Similarly, reduced physical activity in old age increases the rate of bone loss. Then there are certain genetic factors, genes controlling rank L, OPG, and rank. They are key regulators of osteoclast. And variants of estrogen receptor gene, vitamin D receptor gene, they are associated with increased risk of developing osteoporosis. Then calcium deficiency, increased functioning of the parathyroid gland, that is hyperparathyroidism, reduced levels of vitamin D. These hormones influence high turnover form. And decreased estrogen levels, especially in the females post-menopausal. They appear to result in increased secretion of inflammatory cytokines by blood monocytes and bone marrow cells, which stimulate osteoclast recruitment and activity by increasing rank L while diminishing the expression of OPG, compensatory osteoblastic activity. So this is the mechanism of post-menopausal females who present with increased prevalence of osteoporosis. So decreased estrogen due to less function of ovaries. So increased secretion of inflammatory cytokines by monocytes and bone marrow cells. So they stimulate osteoclast recruitment and they increase the rank L activity and they depress the expression of OPG, that is compensatory osteoblastic activity. So body's calcium nutritional state also affect the appearance of osteoporosis. Hormonal influences after menopause. So there are more chances of vertebral fractures and loss of height and various deformities. So radiographic imaging techniques such as dual energy X-ray, absorptiometry, and quantitative tomography, which measure bone density. So this diagram shows the summary of various factors which lead to the development of osteoporosis. So peak bone mass depends on genetic factors, nutrition of the individual, and physical activity, then menopause and aging. So after menopause, there is decreased serum estrogen, increased interleukin 1, interleukin 6 and TNF levels, increased expression of rank L, and there is increased osteoclastic activity. In old age, there is a decreased replicative activity of osteoprogenitor cells and decreased synthetic activity of osteoblasts and decreased biologic activity of matrix bone growth factors. And obviously in old age, you can do reduced physical activity due to weakness or other diseases, and this results in decreased bone mass, that is osteoporosis. Morphology of osteoporosis: the trabecular plates, they become perforated, thinned out and lose their interconnections, leading to progressive microfractures and eventual vertebral collapse. You must note that osteoporosis affects mainly the weight-bearing bones, that is vertebra and then knee joints. Then there are vertebral fractures, fracture of femoral neck, pelvis or spine, and these may lead to pulmonary embolism and pneumonia. So here you can see the reduced mass of, this is the normal vertebra, this is the compressed vertebra affected by osteoporosis. So they are porous, reduced bone mass. So that is about the osteoporosis. So we, and here today.